Okay, the next item is bone development. Basically, the bones are going to develop through a process called ossification, right? Which is the deposit basically of calcium in the bones. So there are two main types of ossification. One of them is intramembranous ossification, and the other one is in endochondral ossification. Intramembranous is called like that because it starts from a membrane. This type of ossification is going to be found basically in flat bones. It goes through a series of processes. There is osteoid tissue here in the mesenchyme. Here you have calcification of the osteoid tissue, which eventually is going to give you the spongy bone. Next one that we have right here is endochondral ossification. Endochondral ossification is basically used for long bones, and it starts with a cartilage. So if we scroll down, you can see here, for example, this is number one. It has a whole bunch of cartilage in there. So then the endochondral ossification starts with a cartilage and is going to end with a long bone, as you can see right here. This is inside one's body, and this is when we are born. You have in here something called epiphyseal plate, which is going to help us grow in length. Eventually, all that cartilage that you have here in purple will turn into bone, and that's when we're going to stop growing. Right here, you have a fetal skeleton where you can see cranial bones. In this case, they are going to be flat bones. These flat bones obviously are going to originate from intramembranous ossification. And right here, you have long bones that are going to start with endochondral ossification. And now we are going to get to bone growth and remodeling. The bone growth in length is going to be done through a process of bone elongation, where we have the cartilage, as I was showing you in the previous figure. You can see right here, for example, in this bone, you see this black line right here is the metaphysis, where the cartilage is going to be found. This is obviously a kid. Why? Because you can see here all these black areas. There's going to be the metaphysis where you're going to have the cartilage. It's not an adult because adults don't have these black lines in here. We scroll down. You have right here the metaphysis where you have the cartilage, and up here you see the bone, and down here you see the bone. Right? Eventually, these areas will no longer have cartilage when everything is going to turn into bone. Okay, so then there's an area here of transition basically between the bone and the cartilage. And you're going to find different zones in there. It goes from zone 1 to zone 6. Zone of reserve cartilage, some of cell proliferation, cell hypertrophy right here, calcification, and some of bone deposition. Okay, you don't need to know that much detail about it, just to know that we grow in length due to the fact that we have areas of cartilage. Again, in my exam, I don't think I'm going to ask you any questions about this. Basically, you just need to know there is a zone of transition between the bone and the cartilage. We're going to have cartilage until we are, I don't know, maybe 14, 15. So if we keep scrolling down, then we're seeing here says, how does a child adolescent grow in height? Well, basically because of the areas where we have the cartilage. Let's keep going. So we have the epiphyseal lane. That's where the metaphyses are, where the cartilage is. Okay. Then we keep scrolling down. Now bone widening and thickening. Bone widening happens based on a positional growth. Basically, in this case, what you're going to have is that more and more bone is going to be deposited on the outer layers of the bone, and that's how it's going to get wider. Let me see if I can find a figure right here. Then we can see the bone in here. So positional growth happens right here. Now, the thickness of the bone happens because as this becomes wider and wider, the osteoclast is going to work right here, and it's going to start removing calcium from this area. And then the osteoblasts are going to start depositing in here calcium. So if we scroll down again to where we were before, right here, we have again bone widening, which I already told you is due based on a positional growth, right? It's going to grow only on the borders, right? Because of the position of calcium by the osteoblast. Okay, and then you scroll down. The next thing that we have in here is bone remodeling. That follows the Wolff's law of bone, which basically says that the bone remodeling is going to be based on the stress that the bones are going to suffer, meaning the more activity that your bone has, the more bone deposition is going to have, and the more remodeling, the more removal of the bone is going to have in order to make the bone more appropriate to withstand the pressure and the forces that this bone is going to get. That's the reason why, for example, bones in your legs are going to be thicker and wider than the bones in your arms, because we are constantly walking, and that stress stimulates more bone depositions. Let me see. Let's go up. Okay, right here. The bones get wider because of appositional growth. The bones grow in length because of interstitial growth, which you should have it right here. So interstitial growth, right? So bones grow in length because of interstitial growth, and bones grow wider because of appositional growth.